And we're told that the bridge has a truck on it at some point. And we're told that truck is located 15 meters from the end, or from the left end, point A. And we're told the truck has a mass of 38,000 kilograms. And we're also told the total length of our bridge is 25 meters. I'll draw that in here. 25 meters. Okay, so, and we're looking for, well, what is the support, the normal force, at point B? Now, to get an idea of what's going on in terms of the forces, I'm going to represent all of those in green. So, we're going to have a force of support at point A, pointing upward. I'm going to call this FA. We're also going to have a support at point B. I'm going to call that FB. Now, there are some forces that are also acting in the opposite direction. We have a force due to our truck being on the bridge. I'm going to call that FT for the force of the truck. Okay? Now, that is a gravitational force, okay? So we can calculate that here in just a moment. Now, the other force that's acting here isn't directly stated, but it's important for us to consider. Okay? Now, any object that has matter is made, or any object that has mass is made up of matter. And what that means is that the bridge itself, because it has mass, gravity is going to be acting on it. Okay? So, because we have a somewhat linear structure here, the center of that object's mass will be right here in the middle. And we can assume that that means we have an even distribution of mass on either side of that center point. Okay? Think back to the lab we did with the hanging meter sticks, right? The idea was that we had about an even amount of mass on either side. Okay? So I'm going to call this force the force of the bridge. Well, we already have an FB, so we'll call this just FG. It's a force of gravity acting on the bridge. Okay? So we have really 4 different forces here, and what this question is asking us is, well, what is let's just make sure, calculate the normal force on the bridge at point B, which would be this force right in here. Okay? What is the normal force on the bridge? At point B. Normal just means contact. There's a support there that is providing a kind of a resisting force on the bridge. So what we need to do, well, is we need to figure out what's going on in this problem to be able to look at our force. Now, there are a couple of conditions we've talked about when dealing with static equilibrium. One of them is that the sum of all forces has to equal 0, and the other is that the sum of all torques has to equal 0. Now, because we have 2 forces that we won't be able to solve for, using that forces approach is going to be a little bit challenging. So, in order to solve this, we're going to use our approach of looking at the torques. Right? So, here's what I'm going to do. We're going to write out our equation. The sum of torques equals 0. Okay? Now, what we need to do is we need to figure out or really make a decision on what we want to be our fixed or set point, what we don't want to move. Now, ideally, we don't really want any point on our bridge to move or rotate. But we have to choose one point that we're going to base all of our distances off of. And typically, we want to choose one of our ending points, and we'll see why as we go through. So, because we want to figure out what's going on at point B, I'm going to choose point A as the point we want to focus on. So what I'm going to say is we want to look at the sum of all torques relative to point A. So, well, we want to look at all the forces that are acting relative to this point, which means we're going to look at our force of gravity on the bridge, we're going to look at the force of the truck on the bridge, and we're going to look at the force of the support at point B on the bridge. Okay? So we're going to look at all 3 of those forces and examine which kind of torques they're going to create. Okay? So, first we want to look at, let's call this our force of gravity on the bridge. So what I'm going to say is that the sum of torques needs to equal 0. So all I'm going to do is sum those up. We'll say we have a force of gravity. Now we're told that force of gravity on the bridge, and well, we're not really told directly, but we know because it's evenly distributed and that it's going to be acting at the center. So 25, we divide that by 2, that is 12.5. So this is a force of gravity, force at a distance of 12.5 meters. Now, because that force is perpendicular to our bridge, we don't need to include the angle there. So it's just force at a distance. Now, you can imagine if we have a force pulling down on our bridge, that's going to create a torque that is acting, as we would say, clockwise. Now, clockwise is what we would call the negative direction when dealing with torque. So I'm going to put a negative in here in our equation. Now, the next force is the force from the truck. Okay? Now, the truck is also pushing down on the bridge, creating another negative torque. So I'm going to subtract minus the force of the truck times the distance it is away from our point A. And we're told that's 15 meters. So Ft times 15 meters. And then lastly, we have the force of support at point B that is working up, that is creating a positive torque. That's going to counteract the other two torques created by the mass of the bridge as well as the truck. So I'm going to call that FB for our force, and this is counterclockwise, so it's positive. FB, and it's at the far end of the bridge, so it's at 25 meters. So what we need to do is set all of these equal to 0. Now, as you'll notice, we have all of our distances already given to us. Okay? What we need to figure out is we need to figure out what this force at point B is going to be. So in order to do that, we need what's our force of gravity acting on the bridge and what's our force on the truck. So here's what we can do. We know the mass of the bridge and we know that it's gravity acting on the bridge. So what I'm going to do is we're going to say that our force on the bridge, leave our negative, is mass of the bridge times gravity times 12.5 meters. We're just saying that our force is a gravitational force, so we can solve for that using mass times gravity. And then we'll multiply by our distance to figure out the torque that's going to create. Now the truck, well, we're going to do the same thing. It's gravity that's pulling down on that truck. So again, we'll take mass times gravity and multiply by our distance of 15. And then lastly, we don't know our force of support at point B, so we're just going to call that FB times 25 meters, and all of that has to equal 0. Sorry, we're running out of room over here. Now, I'm going to put in here, this is the mass of the bridge, so I'll call that MB, and I'll put in here, this is the mass of the truck. I'll call that MT, just so that we can make sure we plug in the right mass at the right location. So, let's plug in what we know. Negative, well, our mass for the bridge was, I believe, 63,000 kilograms times 9.81 meters per second squared, and we'll multiply by 12.5 meters. Okay? Mass times gravity is our force, times distance, minus, well, a mass of our truck was, I believe, 38,000 kilograms. Yes? Times 9.81 meters per second squared. And we'll multiply, again, by our distance away, 15 meters. And we're just going to keep this any kind of train going. Then we'll add, well, FB at 25 meters and set all of that equal to 0. Okay? So you notice these problems do tend to be a little bit lengthy, but we need to make sure that we take into account every force and the distance at which that force acts from a chosen fixed point. So all we're going to do now is we're going to plug in all of these numbers and start to simplify our equation. So I'm going to take 63,000 times 9.81 times 12.5. And that's going to give us a pretty high number. I'm going to do this in red to show that we're now simplifying things down. We still have our negative. This will look like 7725 375. So that would be 725,375 Newton meters. My apologies. And then we'll do the same thing, okay, for the force on the truck. So 38,000 times 9.81, okay, at a distance of 15 meters. And this will give us a negative 5,591,700 Newton meters. And then we'll add that to, well, our force that we don't know at support B, FB, times 25, and set that equal to 0. Okay, so again, all we did here in this next step was that we resolved some of those equations. We found our torque from the mass of the bridge and our torque from the truck and gravity working on the truck. So now all I'm going to do is I'm going to combine these two very large negative numbers. So 7,725,375, that's a negative, minus 5,591,700. That's going to give me, again, a very large number. Looks like negative 13,317,075 Newton meters, plus, well, this other force we're not sure about yet, FB, times 25 meters equals 0. So we're almost through. Now all we need to do is move this negative value over to the opposite side of our equation. So I'm just going to add this value to both sides of our equation. Then it will cancel out on the left-hand side. We're just going to move it over. So that will leave us with something that looks like this. FB times 25 meters is equal to, well, 13,317,075 Newton meters. So now we're at a point where we can take one more step to find our force. So we're going to divide each side of our equation by 25 meters. And that will leave us with a force at point B of about 532,683 newtons. Now, as always with the videos and with your homework, the problems are going to look a little bit different in terms of the numbers. And your masses of the bridge, your distances are probably going to be a little bit different than what I have up here. But we should get, hopefully, a value that is pretty large. But remember, we're talking about a bridge that's very massive and a truck on that bridge that's also very massive. So in order to counteract all of those torques and forces going on, we need to make sure that we get probably a pretty large amount of force. So let's double check and see what we come up with. So it looks like 532,140. We are, barring a little bit of rounding that we probably did in here, right at about 532,600. So we're good to go. Now, again, as I've said before, there are a lot of steps required in order to solve this problem. So just to review what we did. We took our picture, and we drew out all the forces that were acting on our bridge. We had a force of support at point A, a force of gravity pulling on the bridge itself because it has mass acting right at the center, a force on our truck due to gravity pulling on it, and a force of support at point B. So we said that in order for our bridge to be at static equilibrium, all of the torques have to sum up to 0, and we chose point A so that we could learn about point B. Then we really set up our equation for the sum of torques. Gravity on the bridge times distance, gravity on the truck times distance, force of support times distance. And then we started plugging values in. Since these were gravitational forces, we could take the mass of the truck and the mass of the bridge, multiply by g to find our force. Then we used that force and distance to find a torque. We summed up our torques, moved a value over, and divided by distance to find our force at point B. So this is really the heavy lifting involved with problems 8 and 9. And you're also going to see that problems 10 and 11 are very similar to what you see here. So remember, in dealing with statics, make sure to take our time, make sure that we understand how we can get a mass into a force, and also how we pay attention to our directions for torque, what is positive and what is negative. And hopefully, this will get you going in the right direction for problem 8. Okay? Best of luck.